Okay, and our last problem, not our last, sorry, our first problem on the inverse normal distribution. We have a university professor determines that no more than 80% of this year's history candidates should pass the final examination. So he wants at most 80% to pass. What a cruel man. I assume it's a man. Maybe I shouldn't do that. The examination results were approximately normally distributed with mean 62 and standard deviation 13. So I'm going to say X's exam scores. X follows a normal distribution with mean of 62 and standard deviation of 13. So I'm going to write 13 squared. Find the lowest score necessary to pass the examination. I'm going to draw a curve to help us see what we're doing here. So very simple curve for the exam scores. The center, the mean, is 62. So the mean is 62 here. And I'm not even going to worry about putting the standard deviations along each side. What I care more about is that no more than 80% can pass. And I want to know what score you have to pass. So what is the score? Because the axis down here are the scores. And this is what I don't know. I'm going to call this K. I'm looking for this number K. Well, I'm looking for that number so that only 80%, or wait, oh no, Keisha, oh goodness gracious. Okay, so I messed up. This will happen to you too. I'm glad I did. So I want 80% to pass. So I want to know what's the minimum score to pass. And so I want this area here to be 80% or 0.8. If 0.8 or 80% pass, that means that 20% fail. So we have 0.2 down here. And so I want to know what's the minimum score somebody needs to pass this exam. And so I want to know, what does this number need to be so that people pass? What's the minimum score to pass? When you know the area under the curve, then you use what's called the inverse normal distribution. You're working backwards to find the number on the x-axis. So when you're given the probability or the percentage or the area under the curve, then you use inverse normal. The only problem with inverse normal is in the calculator you have to put in the area to the left of what you're looking for. And so I'm actually going to have to use 0.2 here because I want to know the area to the left. Well, I know 80% pass, that means 20% fail. You can talk about that with each other. It's the tricky part about this lesson. And then to find that, you're going to go Menu, Statistics, Distributions, and you should see number 3 is inverse normal. The first thing they ask you is the area, and that's always going to be the area to the left. 100% of the time, area to the left. We know the mean is 62, and we know the standard deviation is 13. And so the minimum score somebody needs to pass is 51.1. I'm going to round to 3 sig figs because it didn't tell me how the test is graded, like by points or percentages. I don't know. So I'm just going to definitely keep 3 sig figs to be safe. The score is 51.1. If you want to write that with notation, you would say the probability that X is greater than K is equal to 0.8. That's what I wanted to know. The probability that X is greater to some value is equal to 0.8. It's a tricky notation, so if you just want to write the answer for these, K is equal to, I forgot what I had, 51.1, I think, yeah, 51.1. If you want to, you can just write the answer. It's equal to 51.1. And just circle the answer. The notation's a bit tricky, but that is the score needed to pass.